Within our third example of a separation of variable problem, we are going to find the particular solution, and we know that we pass through 1, 3, meaning x is 1, y is 3. And then we're told that the slope is equal to this. That means that dy dx then, because slope is dy dx, is y over x squared. We need to separate our variables, meaning we need y on the left-hand side, x on the right-hand side. So we need to multiply by 1 over y. And leave our 1 over x squared on the right-hand side. And I'm going to multiply over my dx. We have now separated, therefore we must integrate. The integral of 1 over y is the natural log of the absolute value of y. To integrate 1 over x squared, that's a general power rule, so we do need to make this a negative exponent and integrate it that way. Therefore, the integral of x to the negative 2 is negative 1 over x plus c. Cannot forget that constant of integration. At this point, it would probably be easiest to plug in our 1, 3. If you want, we could try to rewrite, take everything to the e. Either way, it's going to be rather complex, so we may as well just go ahead and substitute. So the natural log of 3 equals negative 1 over 1 plus c. Therefore, we have the natural log of 3. Notice I dropped the absolute value because 3 was positive. If 3 was negative, then we make it a positive and drop it still. So we're just performing the operation of the absolute value within this. Within this instance, then, c is equal to 3 plus 1. Now we're going to bring this and plug it in. So the natural log, the absolute value of y, equals negative 1 over x plus the natural log of 3 plus 1. And I am going to regroup a bit, and I'm going to group my plus 1 and my plus the natural log of 3 in the back. You'll start to see what I'm doing here in a moment, because now we need to solve for y. To solve for y, we do need to raise this to the e power. E and natural log cancel. We're left with y equaling. On this side, we have e to the negative 1 over x plus 1. And we have plus the natural log of 3. So I'm going to actually break that into another e to the natural log of 3, using the idea that if there's addition in our power, then we know there was multiplication initially. And I did that because natural log and e are inverses. That leaves us with 3. So this expression goes to 3. Therefore, y equals 3e. And I think it might look a little better if we actually got a common denominator here and did x over x. So then that's x minus 1 divided by x. And what I did here is just made this x over x the common denominator, so I could actually combine that into a simplified expression that looked a little better. And that is our particular solution to that equation. If you have questions about any of the algebra, please reach out to me. I'm happy to work through this with you, explain any of the pieces that you have questions about. It was a pretty advanced little example here.